Live from New York, it's Asking Engineers.
Hello, everybody. Welcome to another fabulous, fantastic, now 3 years running Adafruit Asking Engineers. Today we have double the engineers, double your pleasure, double your fun, double your capacitance, but also, of course, double your ESR. It's both me, Lady Ada, the original engineer, and then Waz, the backup engineer. Well, I mean, like, hot swappable. So we will be answering twice as many questions, but unfortunately we'll be answering them at the same time.
Lots of contention. What?
We have lots of great stuff on tonight's show.
Yeah.
Tell them what's on tonight's show,
All
Phil.
right, on tonight's show, we're still celebrating the 3-year anniversary of... This is the third week in a row we're celebrating the 3rd week anniversary.
It's kind of like that.
333. 3 years of Ask an Engineer.
The code is still...
Yeah, we'll get to that in a second. We'll have some news about a free Raspberry Pi promotion.
You want free Raspberry Pis?
Yep, we'll be talking about the show and tell, all the cool things. We got some mailbag. We got some news in the wonderful world of open source hardware. Some new tutorials from Adafruit Learning System. We have a contest we're going to be doing, giveaway at NYC Resistor. We got some news about the Circuit Playground. Take the copper trace to the Circuit Playground. It's very fun. Did a sponsorship. We got Fritzing Friday. Got some new products. We're going to be showing those. We're going to answer your questions. We're going to have a trivia question. We're going to have a cat. Here's some meows. All that and more on Ask an Engineer. Okay, that's a show.
It's a show.
An exciting lineup.
Okay.
Okay, let's do a little bit of housekeeping here.
Yeah,
she's got to do her thing.
Open the beers.
All right.
Today we're being responsible engineers drinking root beers. But they're good root beers.
Yeah.
Cheers.
All right.
Cheers.
Excellent work. Just a reminder, this is 3 years of doing Ask an Engineer. Great to have Waz here because she's been on the show many, many times. That's 3 years. Ask an Engineer.
So great. Who would not want to come back?
Right? Well, you're going to have to come back every week from now on.
Okay.
So the code, once again, for the 3rd week in a row is 3. 10% off. Many kits in the Adafruit store.
Yes, and breakout boards.
The code is 3. So there's that. Some quick housekeeping before we get started. Don't forget, there is only another week to vote for Lady Ada as Entrepreneur of the Year.
Please vote.
Yeah, you can text it with your phone. You can go on Facebook.
I don't want to go to my mom and say, I'm sorry, I lost out to Justin's Nut Butter.
Yeah, so the competition is Justin's Nut Butter, a fair trade group. There's a
Fair Trade Coffee.
Yeah, there's a
which actually, if you're not going to vote for me, you should probably vote for Fair Trade.
yeah. There's a medical company and a service company. None of them are open source hardware. None of them are engineers.
None of them give away free tutorials.
None of them give away free tutorials. I think you're an underdog. You're one of the smaller.
Okay.
You're one of the smaller companies. But
No, I'm the smallest company.
Yeah, but we have a bigger community, I think. So everybody, get out your phone right now.
We're 1 million strong.
Yeah, almost on
Almost.
Google Plus. You're almost up to 1 million people. Very
If you
impressive.
have a phone,
yeah.
please text it. If you don't, but you have a Facebook account, you can also use Facebook.
Yeah.
Sorry about the Facebook.
And as someone said, you're the only one with pink hair in that entire group.
I'm the only one with pink hair, and I'm the only one, I'm pretty sure, that has 2 X chromosomes.
Yeah, you're the only woman out of the 5 and out of the entire 15 because they have different categories. But you're the only woman in the entire group.
Yeah.
So it'd be cool if there was another pink-haired person. That'd be like pink-haired version.
That would be really embarrassing.
Yeah.
Like, oh,
Which pink-haired one should we vote
we
for?
both showed up for the photo shoot with the same pink hair. Okay.
Okay. So let's hop right to the show and tell. We had some excellent folks show up. We have a little list here. So
Waz, do you want to?
Yeah.
Go.
So
Why don't you?
Nick Woods had the...
He had Nick Woods was working on a system for a wood shop where it was basically feeding material into a saw at a constant known programmable feed rate, so you could reproduce feeds rather than having to sort of manually cut things the same length by hand.
Yeah.
Charles showed off the badge that he designed for the EMF conference.
Yeah.
And unlike a lot of other conference badges, he decided to use a very ubiquitous MCUing platform. So he based it off of the Leonardo, got a Nordic module working. It had IR communication too. So that was...
Yeah,
I
think the thing is most badges, I mean, because I'm seeing, we know, Kingpin, Joe Grind, who has done the DEF CON badges. So they get those chips basically for free. So the deal is that, they go to a company that's not a big, well-known company, and they say, hey, Freescale, whatever, donate us chips, and they will. And that's why they use YouTube chips.
Even with the Ninja badges, which were very similar to the Koha Con badges, it was based on the MC13 224V, which is not a common dev chipset. I mean, like, we made it like a dev board, but a lot of people are like, I'm not familiar with that chip. I'm not familiar with that.
Why? Because it was free chips, or just
no, because
like them?
we already knew it.
Okay.
Like, knew the design. So because
here's the thing. Unfortunately, AVRs and PICs are not that cheap.
It's true.
They're not. If you want to go cheap, there's like some of the STMs are like way cheaper.
Oh yeah, but there's a trade-off though between like making it cheap and making it so that other people hack with it. And I think if your goal is to be like a hacker conference badge.
Yeah, I will say that between like Redwire and what's his name who did the Hope badges?
Travis.
Goodspeed.
Yeah.
They really like those chips that are incredibly low cost but very obscure for most people.
Yeah.
So, I mean, I understand it.
Yeah.
And then there was one thing about this that Charles got this wireless thing working that you guys were impressed about. What is this wireless thing that...
It's like these low-cost modules that are like everyone sells, but there's no very good example code for them. So like every engineer I know has these NRF 2401s. I mean, I've had them in a box for like 10 years. And like I never got them working.
Yeah, it's the sort of thing you think of, oh, I'm going to buy this module and I'm going to put it on my board and automatically get this extra wireless functionality, but then actually working with it
it's
is not
kind of a
trivial.
pain in the ass.
Yeah.
It's a great chip, but it's a little bit of a nightmare to work with if you don't have ready to go example code.
Yeah.
Yeah.
Okay.
I mean, I think by now there are libraries for it, but like 10 years ago, like when these chips were hitting the market and they were like, they're like $2 each. They're very cheap, but like no example code.
All right, and then last up?
Last up was Jeremy, and he made a really nice little blinky LED ambient toy for his car that kept his toddler occupied during car trips.
Yeah, that was really good. And then we got introduced to Jeremy's whiteboard. He
Jeremy's
has tons of whiteboards.
whiteboard.
Yeah, I want a show called Jeremy's Whiteboard because I think like the way he does all that stuff would be very interesting for people to see. And then we also learned that maybe those whiteboards that electronically record everything on it is not so good. Apparently
You know, I don't use a whiteboard. I don't like whiteboards.
You're not a whiteboard
I use
person.
whiteboards as reminders, and like when I'm talking to a group of people, but
I'm comfortable. Like nobody writes like this. I write, on a piece of paper. So I like the little note things. So
You do a lot of your circuit exploration on paper. I see them all scattered.
Yeah, and then I
sometimes,
toss them after I get them into Capture. But
yeah.
I don't like drawing on a whiteboard because it's hard to erase and it gets smudgy. And like it's not. Nothing really beats like a pencil or pen and paper. They figured that out. They figured that shit out.
Yeah. Okay. All right. So for everyone who is on the show and tell, if you let us know if you place an order, just let us know. We have these new stickers, as seen on the show and tell, that you can put on your projects and stuff like that. So that's what we do now. Lady Ada, how do people get on the show and tell?
Getting on the show and tell super easy. Just go to my personal Google Plus page and ask to be added to the Google Plus Hangout.
The show and tell circle.
Circle, yeah. The show and tell circle, and I'll add you to that circle because then when we start the show, I have to like invite everybody from that circle. I can't invite you otherwise. So you have to add yourself before the show and tell.
So just post up a comment.
Post up soon, not 5 seconds before the show and tell.
Yep. Okay. Just a reminder: the code is 3. That gives you 10% off many things in the Adafruit store. One quick note with all this stuff. Right now, if you are very strategic, here's what you could potentially do. So, by the way, you can order $350 worth of stuff at Adafruit. That gives you free UPS ground shipping in the U.S. and you get a free Raspberry Pi. So that's one of the new little announcements that we're going to do tonight.
And you can get some 10% off action.
You can get 10% off on your order. You can get a free Raspberry Pi and free UPS ground shipping. This is actually not such a great idea for us.
If you live on like the Eastern Seaboard, you'll basically get it in one day. UPS ground is essentially next day.
Yeah, so
if
we
you
have
live like
this is
nearby,
while supplies
northeast.
last. We don't know how long we can do this with the limited amount of Raspberry Pis that are out in the world, but that's what we're doing right now. So anyone who's
That's
watching,
a nice graphic.
Yeah, it's a little nice banner thing that we have there. So anyways, it's a pretty good deal. Free shipping, free Raspberry Pi, and then 10% off tonight. So it's a deal.
Mm-hmm.
Not for resellers. We can't do that. That's no
Yeah, because we already give them like 40% off.
They already have that. And I think we're one of the few places if you were to order it using expedited shipping, if you don't want to do like ground, you get it the next day.
Yeah.
So that's
a lot of people are picking up like a scope because the scopes are like more than $350. They're like $390, and then they get a Pi, and then they can overnight it, and then we'll just ship it in one box, and I can get the next day.
Yeah, someone really wanted 2 pies and they ordered $700 worth of stuff and emailed, and I'm like, okay, like, that's fair.
Because otherwise they would just have, oh, you have 2 orders and you split it in half. Stupid.
Yeah, so we actually did that. Okay, moving right along. We have some mailbag. Hi.
Oh, look, it's Packet.
I'm Packet, yeah. So here is the mailbag for the week. This one is, hello, my name is Sandy. I'm new to electronics, however, I placed several orders over the past few months, and by far, you've won the shipping game, not to mention your tutorials are superb. I am basically just sending you this message to let you know how happy I am with your website. Absolutely wonderful. Keep up the good work. Thanks. Thank you, Sandy. I'm glad we won the shipping game. I don't want to lose the shipping game. That would be horrible.
Is that like the crime game?
Losing the shipping game. No, losing the shipping game is like sending all of your goods into DevNull. So you're like, I sent it out on the bus, but you know, everyone just lost that packet.
Yeah. Oh, for the person who wants to know, will you get any of the Welsh Raspberry Pi boards? So those won't be in the U.S. for at least a month, probably more.
Yeah.
So those are going to take a while.
We couldn't get them even if we waited. We couldn't have gotten them until October.
The U.S. folks aren't going to get them for a while. Next up, we do have a new countdown clock on Ask an Engineer. If you're in a different area of the world, apparently we have a bug and it doesn't work. But, so Ask an Engineer already happened like 6 hours ago, but we're working on it. We have a countdown clock.
Okay, because it doesn't check the time.
Yeah, you know what you can do.
Time zone.
Yeah. So, anyways, next up, we got some wonderful news in the world of open source hardware. Love that logo.
Yeah.
So there's some stuff coming up. You are reading Chris Anderson's book called Makers.
I am halfway through.
Yeah. How do you like it so far?
It's really good. So he kind of talks about like so I don't want to ruin it. They all
Don't ruin the ending.
No, they don't.
Does he make open source hardware at the end?
Yeah. So he talks about his grandfather was an inventor, and he invented like the time controlled sprinkler system.
Oh wow!
So he kind of invented it. So he talked about how inventors used to get royalties and how they would partner with companies, and he's like, that old system, it was okay, but it was not great. Like, and it's true. Like a lot of people like. You know, you get royalties right up until exactly when your patent, expires, and then like.
Then
it's over.
Nothing, yeah.
So you have to constantly be upgrading, updating, and like, of course, you always have to, but like, they'll figure out any way they can to not pay you royalties because it's kind of deal and it's exclusive. So he thinks that, and he kind of ties this in with the long tail stuff that he wrote about, and he's saying, like, electronics now, because of the manufacturing abilities, it's become more long tail. So, like, somebody who designs a sprinkler system, like, he tried to design his own sprinkler system, like, so you can design one, like, using, like, one of these brass solenoids, for example, or, like, these plastic solenoids, and instead of, spending 7 years of your life and getting a patent and, like, going to a company, you could design a system, have an Arduino, get a waterproof case, put it all together, and then you could sell 100, or like nowadays you can do a Kickstarter and pre-sell like 1,000 just to gauge interest in your project. So he talks about that. He talks about like he doesn't actually talk about open source hardware that much in the book. I mean, maybe in the later chapters, but I don't think so. I think he actually talks mostly about manufacturing and how easy it is to do manufacturing now,
rather than having a company license your invention and have them take over all of the different manufacturing and
I mean, they're still interesting, but he's like, nowadays you can do small scale fabrication so much easier. So that's kind of what the book's about. I mean, like, there's more to it, and then I just got to the part where he's talking about 3D Robotics, which is his own company, and so he talks about like the process of learning how that works, but how they're doing manufacturing and how they do their own pick and placing and stuff like that. Basically what we do at Adafruit.
Yeah. Okay. All right, moving right along. In the world of open source hardware, a couple of weeks, Open Hardware Summit is coming up. Woz, you're doing a talk. What are you doing a talk about?
I'm doing a talk on ergonomics of use and design for manufacturability, which you would think are two dissimilar topics, but they're pretty tightly related, particularly if you're going to make a product. So traditionally, design for manufacturability is like, oh, I've got a plastic widget. I want to, make sure that it's highly manufacturable. So what's a cheap manufacturing process, injection molding, whatever, and you have all of your design be about getting that manufacturing quality up and that price point down. But for open source hardware, a lot of there's a lot more sort of community focus that you have to take into account, because it's like with the inventor being able to do their own small manufacturing production run, right? Because we have small manufacturing capability. So you, as the kit inventor or designer, if you want your stuff to go out to market and get used, you need to think about how customers are going to use things, because that's how you differentiate your kit from other people's kits, but also how you can make sure that more people take and build on your work, which is part of open source hardware, right? That you publish everything and people actually extend on it. So if you put attention into looking at, you know, how someone wants to interface with your board or how they want to build it, if it's going to be a kit and focused on kits, so then you want to design it for hand manufacturing, right? Like make fatter pads, make it easy for someone to assemble, make sure that the way you have it designed for assembly doesn't mean they have to have the best soldering iron ever, or you give very clear instructions on assembly order.
So do you have like a checklist for the stuff?
Yeah, I have checklists that I use for doing sort of cheap surface mount stuff. So like with the Ninja badges, when we made the boards ourselves, how we actually, like I thought about how we were going to make them in order to streamline making 500 of them in a week. And then when we go to like having an assembly house do it, you talk to them about their assembly methods and pick the best design practices for their assembly methods, and that's part of design for manufacturability. Mm-hmm. But it all comes back to how do you want someone to use your device also, because there's always a push-pull between the best way to design something to make it easy to use and the best way to design something to make it reliable and cheap to manufacture.
Yeah.
So that's what my talk is about, basically.
And you know, one thing we should do as well is for the folks who, because we have so many new people who watch, what do you do for a living, by the way?
What I do for a living is I work at the Wyss Institute at Harvard, and I'm a member of the advanced technical team. So our job is to do product technical translation. That means taking something from a research idea, and particularly if it's an idea where you're like, wow, I can really visualize a lot of very powerful applications for that technology, but there needs to be so much product development that goes in order to hit that application market. And we do that initial product development and that initial proving out of you know, can we actually take this interesting scientific idea and apply it to the application field we care about. So it's called, that's called technology transfer.
And someone wants to know, will you be sharing your DFM checklist?
I will, but the big thing is to know that my DFM checklist isn't complete. I learned it from working with very experienced head engineers, and it really depends on what you're doing.
Yeah, but everyone should have a DFM checklist. But your DFM checklist won't be good for me.
Right, because you run things on your own pick and place, so you have your own assembly processes. But it's more of a talk of getting people to think about DFM and to think about end user ergonomics, so that you know, you don't end up building something that people can't assemble, or you end up building something you're like, this is great, you put all of your money behind building it, and then the assembly house says, we can't build that, it's impossible.
And then for like the very new folks, what does DFM stand for?
DFM stands for Design for Manufacturability, and the checklist is very different from, you know, it's one checklist if you're making something like a hand-built kit with through-hole components. It's another checklist if you're making something for wave soldering, or it's another one if you're doing IR soldering, or you know, thermal oven reflow. So it's just all of the things that you need to check about your design to make sure someone can manufacture it. And you can get super optimal. I'm going to be pretty general, introducing the concepts and an example of a checklist so that you can come up with your own.
Okay. All right, let's keep moving. Adafruit Learning System has its own segment during the show now since you've been here, Waz, because we released a learning system.
Because it's so exciting.
It's very exciting. This week on the learning system, we have 2 tutorials.
Yeah.
Lydia, did you want to talk about this one?
I will introduce you short. The first tutorial is by Bill Earl, who does a lot of the tech support for us in the forums. And a lot of people, this is their first time soldering, and so they need some help or advice on how to solder and what tools to use. So he did a great tutorial showing the details of how to solder, what tools to use, how to set up your system, and also what it looks like when you messed up.
Okay. And then next up, we have a specific one that's around one of the components, one of the things we saw.
Yep, we put up a very basic but straightforward tutorial on how to use the DAC breakout board that we have in the store. It's a cute little DAC, and it's really easy to use, but we thought we'd have a little wiring diagram and information on how to wire it up on different microcontrollers and some details about all the pins. So if you want more information, we have that tutorial up.
Okay. Next up, we have some Raspberry Pi news. Just a quick thing here. First off, we're doing that special, so $350 more, you get a free Raspberry Pi. And then we have one announcement and then one video. So we'll take a break and watch this video. Becky did this really cool project. So you can take these laptop docks that are meant for smartphones. So some phones, for a while, like Motorola is like, oh, we know, we'll have it set up so you plug your phone into like a laptop, and now you have a laptop. So it's basically a laptop dock without the computer brains, but you plug your phone into it, and then it turns into like a real laptop. But some people thought, hey, we could probably just plug in a Raspberry Pi and make a Raspberry Pi laptop. So Becky shows you how to do that, and we're going to show you that video right now.
When you get your Raspberry Pi Linux computer, you want to connect a power supply, monitor, keyboard, and mouse to start up with your Linux distribution. And you can use whatever you have around the house, a keyboard. You could pick up one of our monitors in the Adafruit shop. But we also found this really cool gadget that makes it easy and cheap to make your own Raspberry Pi laptop. It's this Motorola Atrix 4G laptop dock. And it's designed to go with the Atrix 4G phone that connects here with micro USB and micro HDMI. That phone has now been discontinued, so you can pick up this guy pretty cheap online. And it has a battery pack on board, a monitor, a keyboard, and a mouse, which is everything you need to make your Raspberry Pi laptop. All you need to do is splice a couple cables to connect right here, and it's my pleasure to show you how to do that. Let's get started. This laptop dock will set you back about $60 on clearance, and we spotted it on sites like Deal Extreme, eBay, and even Amazon. We need to connect here to the micro USB and micro HDMI jacks, and so I picked up a micro USB extension cable, and we'll use that to splice together with a regular USB-A end to connect power and keyboard and mouse. And then I also picked up a micro HDMI female-to-female coupler with a micro HDMI to regular HDMI adapter. That way we don't have to splice any HDMI cables. It's a lot of wires. Begin by cutting your micro USB cable in half and then stripping off the exterior coating on the wires. Place a large diameter piece of heat shrink tubing over the female end of the micro USB cable and begin peeling the casing away from the wires so that you can make individual connections. Still working on that female micro USB end, carefully strip the insulation off of the inner wires, red, black, white, and green. Prepare the other connectors in a similar way, except they'll each only connect to 2 of the 4 wires. This is the USB-A connector that's going to go to the trackpad and keyboard, so we're only going to connect the white and green wires. And don't forget to add that heat shrink tubing before you solder them together. The method I like to use for splicing these wires is to tin each end with a little bit of solder and then position them near each other and remelt that solder so it flows between the 2 wires. Repeat that process twice more with the male micro USB connector, and you only need to connect the black and red wires to provide power to the Raspberry Pi. There's also an uninsulated set of wires or foil. It's for shielding inside the USB cable, and I had some extra, so I decided to connect it. Hey, why not? Lastly, slide your giant piece of heat shrink tubing over the whole big mess. Then just connect your Frankenstein cable to the laptop dock and your HDMI adapter chain, and press the any key to get started. So I hope you'll go forth and make your own Raspberry Pi laptops and show them to me in the Adafruit Flickr pool or on our weekly show and tell on Google Plus Saturday nights. And don't forget to watch the rest of our Raspberry Pi videos, both our own and other people's projects from the blog. And as always, subscribe to our channel here on YouTube so you never miss a video.
All right, here you go.
That's our new Becky Raspberry Pi expert.
Yeah.
Yeah.
Becky is now Linux hacker. Okay.
She will be answering all your kernel hacking questions.
All right, so next up, we have this contest that we're doing. So
Contest!
We'll be at the NYC Resistor event on Wednesday the 19th.
For the Raspberry Pi World Tour.
Yeah, and because of that, we're going to have a post about this. So these are these bags that we got that look like giant Raspberry Pis. This is Tom, who's in charge of receiving, and we made him wear one. And so,
Tom.
Yeah, here they are. This is the big one here. And so we're going to fill this filled with electronics.
Goodies. Yeah, they got these little raspberry bubby.
And for the
nice texture.
for the New York folks, you have to show up with the cool project at the NYC.
Yeah, the winning project that we think is the coolest. Not necessarily the most technically complicated.
Yeah, it doesn't have to be hardcore to be
It
awesome.
doesn't have to be hardcore to be awesome. Although, I do give point to hardcoreness.
But cleverness.
But cleverness and usefulness is also more important. We'll get a bag chock full of goodies.
You can get a lot of goodies
We
in
will
this bag.
chock this full of goodies. We're going to get the chock open and
it's a
stuff
pretty big
goodies
bag.
in it. It's a nice bag.
These
It's
are
like a
nice bags. So here it is. You can see there's a lot of room for a lot of electronics.
This is a good electronics bag. Yeah, we're gonna fill it.
And this is the 47th anniversary of Star Trek, and there's this thing called the Horta. Anyways, I don't want to talk about that. And then we have this little tiny one that we're gonna do something cool with soon. Here, I'm just like I'm off camera now because I wanted to move it.
This is a little mini tote bag.
Yeah, this one we might actually just do a pack for kids, and maybe we'll give one away online for folks who.
It's still good. It's waterproof.
Yeah.
Yeah.
Nice. Yeah, and it's got this little protective thing.
I'm sorry,
too.
it's the 46th anniversry of Star Trek.
Oh, I'm sorry. We have to revoke your
Yeah.
communicator.
Perhaps in this universe, the other one, it's 47. Okay.
Thanks, Comic guy.
All right. So, anyways,
Okay.
so we're doing that, and we'll have more about that on the site soon.
Yes.
Okay.
But we're gonna show that off because it was bubbly.
Yeah. Next up in Circuit Playground news, last week Adabot made a visit. There'll be some more Adabot visits soon. That's Lady Ada and Adabot. Yeah, here is the Circuit Playground, and then we asked everybody to help us name these characters. So the naming is in. It's ready to go. It's done.
Okay. So
here they are.
So we've got
the
Connie?
capacitor.
Yeah,
Cappy.
Cappy.
Our capacitor.
Yeah, Cappy the capacitor is Cappy E electric field.
We've got Ruby, the red LED.
That's right.
And Gus, the green LED.
Yeah, and then Billy, the blue LED. She's gonna sing the blues.
She's very soulful.
Yeah.
You've got Connie, the transistor.
Yeah, for short for silicon.
And, of course, Mo.
Yeah.
Mo, the resistor.
And then Hans.
Hans, yeah, named after Hans Karmazin, I think. Karmazin, the
PC555, yeah.
Amazon.
yeah, Karmazin. And these are all part of Circuit Playground. And special thanks for John Janier and the entire community for helping us come up with these names. They'll be making appearances in all sorts of different ways. The first round of appearances they'll be making is when we have our electronic plushies, and these are in production right now. They'll be out very soon, we hope. And
You can have your own resistor plushie.
yeah,
So happy.
they're so happy to be.
They are unusually happy.
Yeah.
Like-
Well, we're gonna have like the grumpy blue smoke monster.
Yeah, that's
yeah.
true.
Gus is a little grumpy.
Yeah, but Cappy's gonna be totally happy until capacitor plague comes around.
Yeah, that's true.
And it's slightly sad, slightly bloated.
Okay, a little bit more news.
Okay.
Adafruit is a sponsor of the first NYC meetup of flying robots. So there's
I really want to build a flying robot.
Yeah.
I'm getting excited about this flying robot.
There's actually a lot of New Yorkers that are building flying robots, and they have a group, and we're now a sponsor of this event. So
Okay.
check out that on the blog. Next up, Fritzing Friday. You want to talk about these parts later, Ada?
Yes, John Janier did an awesome job with Fritzing Friday. First up, he did his power switch tail, which he did a kind of astonishingly good job. It looks like a real life power switch tail.
Yeah.
So he did this. That's great. He also did 2 battery packs, the 3 times AAA and 4 times AA. Although you could pretend that they were other size batteries if you wanted to. And he got even an on-off switch. Nice.
He's so thorough.
He's very thorough. He's got the DC barrel jack that's breadboard compatible, so you can stick it in your breadboard. That's really handy for your breadboarding projects. He's also got an N-channel power MOSFET. Our 3.7 watt Class D amplifier based on the Max 98306, super awesome amp with 2 speakers there. He also did, what was that other chip? I'm trying to remember. He did the FTDI friend. Oh, and then the INA 219 I2C current and voltage, high side current and voltage sensor. So
INA 219, he says.
yeah, INA 219.
Yeah. All right, so that's what do they call it? We
Fritzing
call it Fritzkrieg.
Fritzkrieg?
Yeah, we just
Like Blitzkrieg.
yeah.
Fritzkrieg.
All right,
So,
we can have the
we got that
Fritzkrieg.
going on.
I don't know if we're gonna have more parts.
He's a Fritzing
Do we have enough
fanatic.
parts to keep him entertained?
Yes, we do.
We'll try to.
Yeah.
Every week I try to come up with new parts.
Yeah. And for the folks who are paying really close attention, every fritzing part will probably eventually be a talking, singing plushie or puppet. It's true. Okay. Next up, I did want to have you talk a little bit about this because Paul is an awesome engineer, developer, firmware writer, and he has a Kickstarter. This is for the Teensy 3.0. Do you want to tell everybody what this is?
Yeah, so Paul of PJRC, Paul suffers in Robin Cook, I believe her last name is, or they have been working on. They did the Teensy, and they did the Teensy 2, which is based on 32.4, which kind of became the Leonardo, so that's really good. And we would like the Teensy 2, and then there's also the Teensy 2++, which is a bigger chip. But I think that Paul kind of realized that, if you want to go real crazy, you kind of have to move away from the ABR chips, most because they're expensive, especially as they get to the bigger ones. Also because there's other chipsets out there, and I guess he went to, I think these are Freescale Stellaris chips, the STMX. I'm trying to remember STMX32. So this is a 32-bit chip. I can't read the part number off of it, but he went to some event, I guess, and he said this chip was totally awesome. It's got USB host on it, as well as USB clients. I believe that you can actually do USB host to that little USB on the go. So that's kind of cool.
Yeah.
And he decided he wanted to try to do Kickstarter for this project. He actually has some boards already made. He knows that these are good, but he just doesn't know how many people want. So he's doing a Kickstarter to gauge the interest and demand. Also, you can get it for a cheaper price if you use the Kickstarter. That gives him an idea. Also, get some fast feedback. If there's a problem, you should find out real fast. So check out the Kickstarter. He already met his goal, and we'll be carrying the Teensy 3 when they get released. We have a pre-order already in. We also back the project. And check out the specs. I've never used these Freescale chips, but Freescale does make very good, low-cost, low-power chips. So, and he says he ported the Arduino IDE to this chipset, and he's really, really good at porting the Arduino IDE to various chipsets. So I believe him.
Yeah, and big news in the Arduino world. Not sure if and when we're going to see the results of this, but Paul now has commit access to the Arduino IDE. So for the folks who wanted lots of changes in the IDE, there's been some positive movement on getting someone like him who has tons of changes in. So join the Arduino developers list and take a look at some of his past changes and maybe help encourage those to get in.
Yeah.
Okay.
Okay.
Before we go
That's
into
all
new
news.
products, that's all the news. Before we do new products, just a quick reminder: the code is
3.
it's code
1,
3.
2, 3.
And it's 3 because we've been doing this for 3 years. This is the third week talking about doing it for this 3 years. Actually, we had a weird start with Ask an Engineer, so it was over the course of 3 weeks that we experimented with this. That's why I decided to do it like that. Okay.
Okay.
It's new product time.
I will do the new products.
New products.
Okay, first up.
Little reminder, we're giving away a Raspberry Pi.
We have Raspberry Pis, but
We got
we're
'em.
not a distributor, so we're going to just toss them in if you order enough stuff.
Yeah, so order $350 worth of stuff.
And you get it for free.
Raspberry Pi.
So actually, we're just giving these away. We're not going to sell them. We're going to give them away.
Yeah. So that's Raspberry Pi. Okay, next up.
Okay, next up I have this barometric pressure sensor. This photo is better than the overhead, so I'm just going to talk over this photo. Can you go to the previous photo?
Yeah.
Just a photo of it. So this is a low-cost barometric pressure sensor. It's the MPL 115A2. It's I2C based barometric pressure sensor. It's much, much cheaper than the BMP 085, which is our favorite barometric pressure sensor. Everyone has their favorite. That's ours. The only thing is that it's cheaper because it's not nearly as precise. It's a 1/50th of the precision, or it's instead of being able to measure I think 0.1 hectopascal, it's 25 or something. So it's not good for altitude detection. It can't do really precision altitude, whereas the BMP 085 is actually precise enough to do altitude based on what the sea level barometric pressure is. It'll calculate your altitude, so that's awesome. This isn't good enough for that, in our opinion, so we don't suggest for that use. But if you're just using it for barometric pressure sensing, you want to know what the barometric pressure is, or maybe you want to do some weather prediction, which you can do with barometric pressure, this sensor is totally fantastic and way cheaper than the BMP 085. So if you don't need that precision, this sensor is great, and we have an Arduino library for it.
And I've shopped around. This is the best deal for this.
And
board.
it's also 3 and 5 volt compatible, so we don't even have to. You can use it with your 5 volt or 3 volt microcontroller. All good.
Don't have to worry about level shifting.
You don't have to level shift anything. That's why the board's so small, and why we could offer it for $15 because we don't have to include all this extra stuff.
Okay. Someone had a question about this. Does our pick and place have any problems with this package?
No, in fact, of the 300 we pick and placed, all 300 were placed perfectly. We had full 100%.
That's like 100%.
100% yield.
Woo.
This was excellent. The paths were very clear on the bottom.
Okay. Someone wants to know, is this good for telling you pressure in a vacuum chamber?
If your vacuum chamber pressure is within the rated limits of the sensor, then yes.
Yeah. Okay.
Check the data sheet for the rated limits.
Okay. Next up, perhaps our most exciting product yet. No, not really.
USB extender.
It's a USB extender cable.
It's a extender cable. Because we have, like, sometimes, we have 3-foot cables, 6-foot cables. This cable is basically just 10 feet long, and it has a USB-A on one side and USB-A male on the other, so you can extend a cable. USB data rates are good for up to 15 feet. That's what they're rated for. But, if you can connect this to a 6-foot cable for 16 feet, it'll probably be just fine. And for power, it's also like, you'll drop a little bit of, this is 28 gauge or 26 gauge, can't quite read it. So, it's not great for like high power stuff, but for an Arduino or something, if you just want to have just enough power so you can like stick your sensor out a window or something, this is great.
Okay. We also put Ethernet cables in the store, but Ethernet cables.
Ethernet
We're just
cables.
going to skip it.
Yeah.
Next up, these displays are gorgeous.
They're bright. I'm going to hold this up because they're bright.
They're very bright.
Yeah. Let me switch over to the other camera here.
We'll show them the overhead. I'm just going to show it in.
Want to go the overhead? Yeah, look at this.
So bright.
These are beautiful.
Bright.
Everything.
Yeah, they're gorgeous. They're a little expensive, but they're definitely worth it. So this is super bright. And I'm just running a simple test here. I have it on the I2C backpack because there's just too many pins to wire it otherwise. But yeah, it's got full 7-segment, 0.56 inches high. It's got a colon in the middle for like time stuff, and it's got 4 decimal dots. It's really nice and bright. It's got a VF of like, 3.5 or something, but all the LEDs are really clear. We're running them here constant current, and they're all really even. And it's a really nice crisp white. Not too cool, not too warm. Yeah. And then we also have it with the backpack because it's really tough to control this many LEDs with that one. So our handy I2C backpack uses I2C. You can have up to 8 of them on a bus. And we have Arduino code and everything, and also Raspberry Pi code to control these, so these are super easy.
What's the difference between the regular LCD display and the one with the I2C backpack?
The backpack just makes it a lot easier to control them because you don't have to like constantly multiplex all the pins. Without it, I think you need like 14 digital pins, but with I2C you'll need 2. Okay.
Then here's some more photos of it. A couple of people want to know, or one person asking twice, does that code that you're running come with...
Yeah, this is the example code.
That's the example code. Right on.
We just load it up.
Okay.
Yeah, it's cool because it looks fake in this photo.
Yeah.
That's
like,
a real photo.
That's actually the photo. It's actually like so even that it just looks, it's
really
all white.
Beautiful. Okay. Next up, we're selling wallets now. And I actually
These are really great wallets.
Yeah, I actually have one.
These are RFID-blocking wallets. They're made out of stainless steel fabric.
Yeah.
We actually bought one of these wallets 2 years ago, and we carried it around for 2 years.
Yeah. So this
and then we were like, you know what? These wallets are so great. We should carry them in the store. So I'll show this off real quickly.
Yeah. So since we sell RFID things, people always ask, well, do you have
well,
blocking stuff?
It's a good match because like a lot of people are like, well, I have RFID stuff, but I don't want it to like always be readable. So this is a stainless steel fabric, and the fabric wraps all the way around, so it completely blocks our stuff altogether. Yeah. And inside it's got like card slots and some slots in here.
Make sure you don't take cards on.
No, I'm not going to show anybody your age or your real name.
I don't care about that. I actually don't care about anything. Just I don't want to like have to like call in my Amex or anything.
Okay, no, I'm not going to pull anything out. It comes with this high quality leather strap here, which is really cool because it means that it's flexible, but it won't crack. It's not like made out of. That's the problem with having it made out of. Like pleather or like vegan and stuff, it'll crack and break, and so we decided to go with the high quality leather. We'll see if we can carry also the one that's made out of all steel, because that way if you don't want to have leather products, we can have that too. So we have to ask them about that. Yeah. And so the one we had lasted 2 years, and it was still in really good condition, and it wore very nicely as well. Yeah. So these are really sweet.
This is one of those times where like, we find something we like, so I had it for 2 years, and I'm like, we should just stock this.
Yeah, I mean, it's not like directly an electronics accessory, but we do carry RFID stuff, including RFID stickers and RFID cards, and like people come to us to get RFID stuff, so we thought, well, this is an RFID blocking wallet.
Okay.
It's cool.
Let's keep moving on.
It's also a really good gift for an engineer because like engineers are like, this is great. This is Rfid-Blocking.
Engineers like that. Okay, next up we got these valves. You want to do these all at once, and then
Yeah.
we'll get into a product. So here they are. These are these valves. You guys like this.
Yeah, I'll show this on
Then
the
we're
overhead.
getting into the questions. All right. You want to do it on the overhead?
Mm-hmm.
Okay. All right. We
Okay,
have
so the
valves.
first valves, these are solenoid valves. So here is a coil, and there's a little metal core inside, and when you apply 12 volts DC to these two, it pulls on the inside and it opens up basically the connection between here and here. This one is the lower cost plastic one. It's probably good for like gardening stuff, gardening projects, or like other like watering projects, but like people tend to use them for like automated sprinkler systems or something like that. So this is what it's ideal for. There's a little filter so you don't get like gunk in it. There's a little metal filter, and I took one apart and destroyed it to show how it works. So this is the tube, and so water comes in. There's actually an arrow that says which way so water comes in through the filter, and then it bubbles up around here, and then on the other side that I took off, there's this rubber gasket, and it's kind of hard to see, but when it gets pulled, when the coil activates, this gets pulled and the gasket pulls away, and it opens up the seal here, and so water can flow. So the thing about this one is this gasket actually, you do need a little bit of pressure to open it, like once it releases. So this isn't for standing water, and it has to be, the water can only go one way. It has to push out onto the gasket to open it. So this is only good for like when you have water pressure over a certain amount, and I think it's like 0.1 psi, or like one, I don't know, it's like 5 psi or something, but it's in the tech docs exactly what the pressure is. But it's good for like anything where you have a pump, but it's not good for like gravity fed water or anything like that, or if you want to have bidirectional water flow. What else about it? We tried to use it down to 6 volts and it still worked, so you don't have to use 12 volts. If you have like a 9 volt power supply, you might be able to do that as well. We also have a brass one, and these are used in water heaters. This is what these originally are for. These are actually, they're much more rugged. They unfortunately need a lot more current. They need like 3 amps or so. This is a really big coil. So it's like 3 amps at 12 volts, and I think like 2 amps at 6 volts. These, however, do not have the issue with the pressure. So this is, I'll show you on the inside. It actually opens up the gasket like really well. So you can use this with standing pressure water. It's also bidirectional. So if you want to open up a valve to connect, 2 bodies of water, you can do that. It's cast brass, and then it's machined, so it's machined really flat. And it works on the same basic principle as the other one. The water comes in here or the other way, and then bubbles up here, and then this gasket is what lets it through. And so when the coil activates, this gasket moves up and down. And this gasket's made out of nitrile rubber, and this is made out of brass. So even though this one is not, they're not rated for food safety, this is not like a FDA approved rated device, anything that is okay with brass and nitrile rubber you can use. So whatever you decide to use it with, just check in like the MSDS for nitrile rubber or your fluid, and just make sure it's good use for it. This is also really good for like a gardening project or pool project. It'll last a lot longer outside than the plastic one, so if you want to like control outside water stuff, I think I'd suggest the brass one. It's a lot more rugged. The nice thing about these is they use 12 volt DC, not AC. A lot of like sprinkler projects require AC, and then like kind of a pain in the ass, because then you're like, where do I get the AC from? Or some of them are even 120 volts AC, which is kind of not good.
I really don't want to ship 120 AC around my yard, except for when I have it coming into the house.
Yeah, but we have seen a lot of solenoids that use it. So this would be good for a lot of like gardening projects, pool projects, aquarium projects. I think if you're doing like an at-home like beer refrigerator, this would probably be okay. I mean, this is not okay for food production, but for like a home project, as long as like your liquid can touch a nitrile rubber safely, then you're pretty good to go.
Okay, very good. Someone knows that failing close.
Oh, sorry. Both of these are by default closed, and you have to activate them to open them.
So fail closed then? Is that what
Fail closed.
Yeah.
Yes.
Natural, like normally closed.
Yeah.
I mean, I don't know what your failure mode is. If your failure is that the power is applied to the coil, it will fail open. So, they are normally closed, and you have to apply current to the coil to open them.
Yeah, I once, for a project at work, had a solenoid-driven pinch valve, and I actually selected it to be normally closed because that made sense to me. Like, oh yeah, like when I'm not driving it, I want that to be shut, and the side for the spring return to be on to force it shut.
Yeah.
Then I'm like, I just made a fail unsafe device because like if you lose power, air pressure for any reason because it was a pneumatic solenoid valve, then it would be a crush hazard. I'm like,
okay.
Would have been better to have it configured to fail open.
Usually for actually it's interesting. Apparently the brass one can also do air. It's actually airtight. So you could do air with this, although
Someone's going to ask, is it airtight?
It is apparently. I mean, it says like that this was used for. This is specifically designed for water heaters and for apparently like also like oil. You can use it. It's because the NBR is oil safe. Although I don't know anything about that. And also apparently it's airtight. Although I don't have a compressor with a 1/4-inch NPT threads on it, so I don't know how I would test it. But I believe that this is they're both 1/2-inch NPT nominal, so it's that's really really common. Almost everything has an adapter from 1/2-inch NPT nominal, so I don't think you should have any difficulty with it. No, local hardware store will have any adapter you need from 1/2-inch.
So I think you can buy brackets on these to mount them on the stuff. So we should try to find those brackets. If anyone knows about those, email us.
I don't know about brackets, but this says
for this lug.
No, this is the lug for attachments. But this one has these really nice
Those look like 1/4-20.
Yeah, they're not 1/4-20. They're probably metric actually. But you could extend, use very long versions and then bolt it into something.
My concern about using this for air would actually be the 1/4 NPT threads. Like attaching things and like actually trying to get like a nice. It's a lot easier to get a watertight seal than it is to get an airtight seal when you're like screwing pipes together.
Dude, I don't know. I'm just saying apparently it's spec'd for it. But what I got these for are people who are doing people are saying, hey, I want to do like a pool project or a gardening project. I want to control like sprinklers. Yeah. And we got a lot of people requesting that. So that's what we are carrying these for. There are if you want to like go and get like hardcore valve solenoids for air for food manufacture. McMaster Car will sell them to you for $500, and you should totally use those. But if you're just doing a hobbyist project, these are probably just fine. Yeah.
Okay, that was new products. Good work. New products. That was new products. Okay, we're gonna dive straight into questions.
Okay, this is like Woz question week,
and everyone loves to ask Woz questions. So it's time for Woz to drop some knowledge. Ask your engineering questions. Go. All right. Starting an EE degree, likely specializing in fields and waves, how many differential equations have I signed myself up for? Also, any math I should brush on before Calc Intro to DE?
You are going to be doing 4 years of diffie.
Well, actually, no. So if you are doing... Basically, the really nice thing about engineering is everyone likes to do algebra and differential equations are hard. So you have to do a lot of differential equations for the beginning of double E. Like you have to learn everything in the time.
And by beginning, we mean 2 years.
2 years. 2 years. 2 years of diffie. But when you start working with things in the frequency domain and you're looking at energy transfer over frequency, there's this really nice thing called the Fourier Transform, and then you actually, in Laplace transforms...
Yeah, but if you're doing field and waves, aren't they going to be like, you have to do like integrals for the rest of your life?
You do have to be able to do a lot of contour integrals, but it's also that when you're looking at RF circuits for, antennas or whatever, you look at them in the frequency domain, which is effectively an algebraic representation of differential equations. So.
But they're only 2 years.
Yeah, and also if you ever want to do stability and controls and look at sort of Nyquist stability criterion, you'll have to go back to differential equations for that too. So anytime you want to get deeper into engineering, it's break out that DiffyQ textbook because it's going to be a fun ride.
Okay.
But you don't really have to bone up. I mean, they'll walk you through the math you need.
Okay.
You probably only need to use calculus.
Yeah, calculus. The other thing is complex algebra was really handy when I was taking.
You also need to know matrix algebra.
Yeah. Oh, yes. You have to take. Yeah. You have to know matrix math. You have to be able to solve eigenvectors. So.
Yeah, because otherwise your diffie Qs can be a nightmare.
Yeah.
All right. Well, that all sounds really scary to a lot of people. So a lot of people are like, I think I'm just going to stick to
Matrix algebra is really easy, though.
It is. It's really easy. And, like, the really nice thing about math for engineering is it's not like you're learning math in a vacuum and you're like, well, I'm learning, like, matrix math and it's internally consistent, but I have no idea what it's good for. It's you learn math and then you apply it to a problem. So really good engineering curriculum will have, here's the math, and here's a theoretical problem, and then here's a practical problem. Use the math on the practical problem, and you're like, oh, right, that's why I needed to learn this. So there's not usually a disconnect between the math and the engineering.
Okay, well, what's on your shirt? It has like a circuit diagram or something.
This is actually the logo of the Chaos Computer Club, so it's ripping a bunch of phone cable out of, out of an access port.
It's apparently it's a joke on a logo for like the internet company.
Yes.
But I don't know the name of the internet company.
They also do a lot of jokes on, they have a joke on a logo of the German Postal Service, particularly after a law was passed for IP traffic logging.
Yeah.
So they're very sassy over there, those Germans.
Someone wants to know if are we going to sell the Occidentalis Raspberry Pi OS on a SD card one day?
We might, but right now it's totally free to download.
Yeah.
So we suggested you that.
Yep.
We don't want to sell until we get to maybe version 4.
Yeah, once we get to
once we feel more confident.
Let's see. When will our 7-segment backpacks be available again?
Hopefully tomorrow morning when we finish QAing the ones we made.
All right. Next, when working with a magnetic transformer with just a full wave bridge rectifier, can you just use big caps to clean up the power?
Yeah, but you don't know what you're gonna get. You'll get power, but like
caps are really tricky because like some caps are really awful and some caps are great.
No, you can use a big electrolytics for that, for a full wave rectifier and like a magnetic transformer.
I guess
it's fine, but you just don't know what a volt. Yeah, you did. You totally did.
Is this motor compensation?
No. It's just like you did this in like 6-101.
I never took 101.
Oh shit. Anyways, I did this. Sorry.
You did this.
I was projecting. You can do it, but you don't know what voltage you're gonna get, so you should use a regulator. Unless you really don't care what voltage you have.
Alright. Next up, do we have any debounce code for the Raspberry Pi that uses use sleep instead of delays?
No, I don't think you need to really do that much. I mean, if you just measure once every 10 milliseconds, you don't have to debounce.
Okay. Next up, Waz, what are you drinking?
I am drinking Boylan Bottling Company's cane sugar root beer.
Okay. Next up, getting in the hot air solder paste soldering, what paste do you recommend?
I just basically use what's the brand name?
I'll use Kester.
Kester, yeah. So,
I use Amtech.
Yeah, I usually use a Kester paste. The biggest thing about soldering paste for whatever your application is, don't let it get too old. Like, don't store it at room temperature. Refrigerate it. It does, like, keep in mind that it expires. So if you get, a discount deal on 50 tubes of solder paste, don't do it. Like, buy it as you need it. Like, if you load it into a syringe for dispensing, toss the syringe when you're done. Like, don't try to reuse it. Like, just load it again from the bulk container. That's the biggest thing. So you want to...
You can buy syringes. You can just buy syringes.
You can buy syringes, too.
But yeah, in the summer you have to be careful because you have to overnight it.
It's more about, like, don't use it old. Don't let it get too warm. Dispense it quickly. And don't let it sit out. The other thing is... if you're not careful, if you don't have the hot air gun on, and this is true if you're skilleting or anytime you're using solder paste, if you get it warm but don't get it hot enough, you can bake the flux out and then it just won't flow. And when that happens, it'll sort of like turn a yellowish brown and look really matte. So, make sure that your hot air tip is close enough to really reflow it. It turns bright silver, then you pull it off. Like that's what you want to do. If you have a low skillet temperature, it'll bake all the flux out too, and it'll be really
yeah, you have to ramp the temperature fast. That's why they say ramp the temperature within like 2 minutes.
Yeah, and you can actually, for most solder paste, they'll show you like what the ramp and soak profile needs to be for reflowing it.
Okay. Someone want to know when we're moving. We don't know yet. We want to move very soon to our new space.
Someday.
Very soon. Well, I saw the space today. It's coming along. Here's a good one. What's the easiest way to learn about the math and physics behind DC circuits because I'm in a competition and that's what the event involves knowing?
Ohm's law?
I don't know what they mean by DC circuit.
Well, DC circuit, so for DC circuits, capacitors are...
The math behind physics, the math and physics behind DC circuits, yeah.
I don't know, I think you should probably talk to the people who were in the competition. They should tell you what you're...
Yeah, I would think a lot of that would be.
We don't know
for
anything
the
about this competition, so it's very hard for us to tell you how to cheat at it.
No, it's not cheating. Probably what they want to study. Okay. Next up, is it okay to route your PN532 board inside the antenna?
I wouldn't. I mean, you want your antennas to have nothing inside of them.
You really don't want anything around your antenna at all. Like, it will interfere with...
We
the way
designed
the
that antenna to
works.
be very good. There's a reason it's very good.
Is it an inverted F?
No.
No, wait, which antenna is this?
It's an NFC antenna.
Oh, that's like, yeah, you don't want to put things inside.
Don't put anything
material,
metallic.
Like,
Yeah.
and for that matter, you generally don't want to put metal above or below your antenna. I mean,
Yeah.
your antenna needs to be
That's
hanging
why it
out in
sticks
free
out.
space in order to be effective.
We have it stick out. That's why we get like 10 centimeter range.
Think of your antenna as, you know, actually someone did a really good visualization of this. I forget what the group was, but they used, basically attached an NFC tag to an LED to show sort of the area of effect of the antenna.
Okay.
And they're really, you posted it on the Adafruit blog, but it was like 6 or 8 months ago.
Yeah.
But if you can basically look at like Wi-Fi or antenna effective distance visualizations, that entire area is the area of effect of your antenna. And if you put anything else in that area, you will mess with your antenna.
Well, if you have a coil, right, it's the center of it where you get the most
flux density.
flux
Yes.
in the center, which is exactly where you would be putting your circuit stuff.
So you really want to...
So you're basically
send
destroying
it
your
there.
flux. You have to have the middle as empty as possible.
Yeah.
So you have the most flux, and then you don't want anything on the outside as much as possible.
Well, no, because if you think
but
of
the
it,
inside is the most important.
the inside is very important because so it's right-hand rule, right? So if you've got current going around your antenna, then the electromagnetic waves are going around it, you know, following the right-hand rule. So you can imagine it's just like magnetic poles. All of them go through the center, and they're more dispersed around the periphery of the antenna.
Yeah.
But you really, I mean, that's why you have a keep
That's
away
why it's
distance.
like right above and right below. That's exactly where the flux hits
Yeah.
it all at once.
Yeah, and so that's when you get like the most effective energy transfer. So
And that's why we designed it that way.
Yeah, so don't route things near it. And in fact, like anytime you see an antenna on a board, it'll usually be kept a little distance away, like
Well,
even
that's
if
the
it's an
problem.
inverted F.
Really crummy ones. Like people are like, oh, I know. I'll just like there's all this empty space.
You can do an experiment if you really want, and like lay out part of the circuit in there and compare the effective performance before and after.
Total crap. Also, it won't be tuned anymore. Like we tuned the antenna.
True.
Okay. Someone wants to know, does release early and release often apply to open source hardware? I say yes.
I would do that, but I release infrequently.
Yeah, I would say for us.
I try to release often and release correctly.
Yeah, because if you release early and often and you release incorrectly, then everyone looks at your project and goes, "What the hell? I can't use it."
I actually do not go by the F it, ship it.
If it compiles, ship it.
Yeah, we don't do F it,
No.
ship it. I mean, the goal is to release really good stuff on a frequent basis.
Yeah, but I don't release
But
something
that's a
until
really
it works.
hard. That's a high standard to hit. Like
Yeah.
correct every time.
That's why like we have projects that are 3 years old
Yeah.
Yeah.
that don't get released. It's like I'm not going to release it until it works.
Yeah. But generally speaking, the fact that you give away your intellectual property means the only thing you can really do is keep a really good
Track
release
record,
schedule.
yeah.
So you have to have a regular, shipping schedule. We have to ship hundreds of orders per day. And then you have to come up with really good stuff.
But that proves that doing open source is a labor of love and takes dedication.
Yeah.
I would do more if I didn't have a day job.
Yeah. Yeah, our day job is releasing open source hardware. So our opinion is like we better get good at releasing stuff fast because that's our competitive advantage because for whatever weirdo reason we believe in giving away everything.
Yeah.
There's something
That's
wrong
true.
with
We
us.
have to release quickly. We have to release quickly, but it also means we have to finish stuff.
Yeah.
Quickly.
And just like Lamore said, I mean, there is one other way to do it. You can release a lot of stuff that's just not good. And eventually your customers just get tired of you. And that's not what we're ever going to do. We'd rather wait. Like, we could probably release something every single day.
It's not
but
even
we're
that customers get tired of you. It's that people who are trying to work and collaborate with you through your designs are like, I don't want to have to error check that again. And it's not going to...
There's a lot of...
you burn out people's trust.
Yeah, there's a lot of companies that sell a lot of stuff, and we're usually the next company people buy from because they're like, wow, never again because I bought this thing, it didn't work. I'm just going to buy from Adafruit.
Our forums are full of like, I bought this thing from like eBay and
Yeah.
like it didn't work, and we're like, well, we can't.
It's eBay.
Yeah, sorry, eBay.
Yeah.
Okay. Let's see. What's a good place to find an assortment of AC main transformers?
I don't usually work with mains.
You can like buy them from like any electronics like online supply shop, but like, you know, I used to get them from like well, you can get stuff in the trash because like they last a long time, and like ham radio supply places usually have them. They still do stuff with mains.
I guess I'd check You Do It Electronics if I were.
Oh, you can just get like an AC adapter. It's pretty much the same thing.
I'm pretty sure McMaster probably has some.
Oh no, I don't know.
I don't think so.
No, they don't. But DigiKey has a couple, but they're expensive.
No, I wouldn't buy like industrial level stuff like that from DigiKey.
But like, I would just use an AC transformer, like just a plug transformer. It's the same thing, but protected. Why stick your hands in it?
I think there are a lot of probably specialty vendors, and you would have to go find a vendor of that type of equipment and then pick something from their catalog.
If you need something for like mega amps.
Someone wants to know where the cat is, and they're right. It's 11 o'clock.
Oh,
we zoomed through that. Thank you so much, Waz. You got
no
through all
problem.
those commercials. It's commercials. The doctor's questions. Someone was just saying there's too many commercials on Ustream. If you don't have an ad blocker, sorry. I'm reading and trying to think at the same time. Anyways, thank you for
all right. Good
answering
job.
all those questions. Now it's trivia question
Waz
time,
knows
everybody.
all.
What are the rules of the trivia question, Lady?
Rules are, if you're a friend of ours, you can't enter this contest, but you know that already because it's been 3 years we've been doing this. The first person to answer the question correctly with spelling and all that good stuff that we see in our chat is the winner. If you have won something from the fabulous Adafruit Ask an Engineer giveaway, we ask that you do not enter ever again because we will not give you the prize. Let somebody else win.
Yeah.
Don't be selfish.
This is the prize this week. So Bunny won an EFF Pioneer Award.
Pine Award.
A Pine Cone Award. No, and this is a NETV, one of the original ones that has the Chumby branding from a while ago. So this is
back when Chumby was like, we're totally going to sell the NETV before.
Yeah, so this is a collector's item.
They ship it in a burlap sack.
Yeah, this is a.
So it's an NETV. You get an HDMI cable and a power adapter and all that good stuff. Yeah. And I think this is. Yeah, it's got the little Chumby guy on it.
Yeah, so this is a collector's item. All right, you ready? Yep. We're gonna do this trivia question. First person to type this in the chat gets it. A little bit of an anniversary for lots of things. 46 of Star Trek, but that's not going to be the question. Who invented Scotch tape? Who invented Scotch tape?
I love Scotch tape.
Who
was
invented
he Scotch?
It? What?
Was he Scotch?
Was he Scotch? No, there was no Scotch. All right, budget engineer Richard Drew, you got it.
Nice.
This is the guy right here. Richard Drew, 3M. He invented masking tape and transparent cell phone tape in the first modern pressure-sensitive tapes.
Oh, that's nice.
Yep.
He's really got that tape down.
More you know.
Yeah.
He knows a lot about tape.
Everybody who invented things back in like the 50s,
looks like that.
Kind of look like this. So.
I want you to get this cat.
Yeah, I'm gonna get this cat. You guys can chat amongst yourselves. Maybe you can show some things.
What do you want to show?
Well,
here,
I think you should hold up
some solenoid valves.
No, I really like this actually. You can tell.
What are you gonna do with it?
I keep on meaning to make a raised garden bed, but what I was really admiring about it was you can tell by looking at the surface texture and the surface finish that it's cast, and I'm like, wait, but there's such smooth finished faces, and you pointed out that it's machined afterwards.
Yeah.
Because
you cast it to get the basic shape, and then machine it to make it precise.
Yeah, you have to have the precision face to interface with that gasket. And the other thing is, I'm wondering how the butyl rubber holds up, but I think that's pretty durable stuff.
It's actually, I looked it up, and it even though this is not official food grade NBR, it's used for everything.
Well, for thermal cycling, how does it hold up over winters and thermal expansion?
It's actually fine as long as you don't expose it to the sun. It just doesn't like it when it
doesn't like UV exposure.
Yeah, so but you can't. It's not exposed. It's inside the breast insert, so it's
okay.
Fine.
It's fine for pulls. Well, let's get us close up. Here's a house cat. I must have doing meow. Meow meow.
No, be nice. Be good to Muffet.
I think he's
such a good cat.
Yeah. All right.
Oh, Moss.
He doesn't mean to be scared, but he just doesn't completely understand.
Well, last question someone has is, we have any plans for Maker Faire? We're gonna attend. We might be in the middle of a move, so we'll be walking around. We'll be there.
Cat.
Good cat.
All right. Special thanks to Becky, George, John Janier, all the Adafruit team. Waz, thank you for being part of Ask an Engineer all these 3 years. Waz gets a hug. Made Ask an Engineer a fantastic, very rare and unique internet show. There's nothing else like
With
it.
cats.
Yeah.
You can use him to generate electrons.
Whoa.
Yeah. We'll see you guys at
And air pressure.
at maybe Maker Faire, maybe at Open Hardware Summit. Waz, your presentations will be
Your
posted
big
later.
event, okay.
Okay. And thank you, everyone. We'll see you next week.
Solenoid cat is solenoiding.
Here is your moment of Zener.